All right, so last lesson we started looking at this quadratic equation. We found out that the quadratic equation, it always had an x squared in it, or maybe an x times an x. When we graphed it out, we got a U shape, sometimes up, sometimes down. And we also found out that in the table of values, we always had the second differences being the same. Now, today what we're going to do is we're going to look at some different properties of quadratics. So there's a couple new terms that we're going to look at that will describe different things about the parabola, or maybe different points on the parabola. The first one we kind of talked about last lesson, which is the direction of opening. So in this case, you would either say a parabola opens up if it's a U shape, or it opens down if it's an upside down U like this. It can never open sideways. That would fail. There's something called a vertical line test where we go through and see if it's a valid function, and you can't have a sideways parabola, so it's only ever opening up, happy, opening down, sad. So in this particular case, we would say this example is a parabola that opens upwards. You'll notice sometimes I'm saying quadratics or parabolas. They're kind of interchangeable. We say it's a quadratic equation, and the shape of the graph is a parabola. But I'll kind of use both those terms interchangeably. The next big point we talk about is the vertex. So the vertex is just the highest or the lowest point on your U. So in this case, we have our U here, and it has a lowest point because it's opening upwards. So here we would say that the vertex is just the lowest point here that it gets to. And if we got the coordinates of that point, it would be -1 and -4. So here I am. The vertex for this particular example was this point here, -1 and -4. All right, next one. Another property is called the axis of symmetry. So the axis of symmetry, this is a vertical line that's going to split your parabola in two. So what we notice here is that these parabolas, they're always symmetric, meaning that one side of the parabola always looks exactly the same as the other side. You could take that parabola, and if you folded it in half, it would always look exactly the same on both sides. So in this case, I mean, I could take a line here, and I could kind of draw it right in the middle there, and split that parabola in half. And that line there is called the axis of symmetry. And in this case, we would just say wherever that the x value is that shows up at. So in this case, I would say at x equals -1, I get this nice vertical line that splits it in half. My axis of symmetry is x equals -1. And you'll notice that that always matches up with where the vertex is, right? That vertex always lands on the axis of symmetry. If you're splitting it in half, it's always through that vertex point as well. So these negatives ones match up here. All right. Next point is called the optimal value. Optimal being the best value. In this case, what is the highest or lowest value, y value, that it gets to? And that depends on the direction that it's going. In this case, it's opening upwards. So in this case, it'll go up forever, but there is some lowest point, some minimum that it gets to. And in this case, if I look at my y values, I say, okay, the lowest down that it gets to would be a -4 on the y value. So I'd say a minimum or a lowest value of -4. Now, if my parabola had opened the other way around, if it had been an opening down parabola, then I would have a highest, a maximum. Right? And the last two are just your x and y intercepts. And these are no different than in a linear equation, right? X-intercept, where does it hit the x-axis? Y-intercept, where does it hit the y-axis? So in this case, x-intercepts, sometimes we call them roots or zeros. And we'll come back and see that a little bit later and why we use those terms. But for parabolas, we'll kind of interchangeably use x-intercept, root, 0, they all mean the same thing. The x-intercept, where does it hit the x-axis? So in this case, we can kind of see here already, parabolas, sometimes they actually hit twice. And this one, in fact, does. It hits here at -3, and it also hits here over at 1. So in this case, x is -3, and also x is 1. There's two different x-intercepts or roots here. And the last one, last property is just our y-intercept. Where does it hit the y-axis? And in this case, it hits right here, hits the y-axis at -3. So y equals -3. So these are really no different than your linear equations. It's just that the x-intercept might happen twice for parabolas. You can kind of think about how you'd position a parabola. For parabolas, sometimes you'll often get two x-intercepts, but you can actually get a case where if the parabola is above the axis, the x-axis, you actually don't get any. Or sometimes that parabola sits right on the x-axis and you only get one. All right, so we got a couple practice ones here. I'll go through and do the first one with you, and then you guys can try the next ones out here. All right, first practice one. So looking at this guy, looks like the direction would be opening down. The vertex, that's the top or bottom point where it turns. So my coordinates here would be 1 and 9. Axis of symmetry, that was that vertical line that we could kind of split the parabola in half with. In this case, it would be right here. So in this case, axis of symmetry, x equals 1. Optimal value, what's the highest or lowest point? In this case, it would be the highest point it can get to, the highest y value it can get to. Because it goes down forever, it just keeps going down and down. But in this case, it goes up to y equals 9. That's the highest it gets to. I'd probably say y equals 9. My x-intercepts, it looks like it hits the x-axis twice. It hits here at -2 and at +4. And the y-intercept, it's hitting the y-axis right here at y equals 8. All right. So the reason that we're using these points is that when we start to model different things with these parabolas, sometimes these points will tell you something important. So oftentimes the vertex is an important point. So for example, if you're modeling maybe the height of a projectile that was launched, the height of a ball that was launched. In this case, you might want to know what is the highest it gets to and when does that happen, and that would match up with your vertex. Or maybe this is modeling some sort of financial situation. Maybe you're modeling profit. And in this case, you might want to find out, well, what's the highest I get to? What's this point up here, right? If I can figure out how to get to that point, I can, get the highest profit. So in this case, maybe, what price do I need to set for my item I'm selling to get to the maximum profit? That might be your vertex right there. Right? So oftentimes these points will match up with something we're trying to figure out. Or if you're looking at the ball, right? Maybe when does the ball hit the ground? When is its height 0? That might match up with your x-intercepts. So in this case, it's important to be able to pick out these main points because they often match up with something you want to find when you're modeling using a quadratic. So at this point, I would say maybe pause the video and see if you can try the next two examples out, and then we'll go through and let you double check your answers. All right. So hopefully you had a chance to try those two out. Let's look at our next parabola here. Go a little bit quicker here. In this case, direction opening up. Vertex was at 0 and -3, the bottom point. Axis of symmetry was right along here, which would just be x is 0. Optimal value, the y, so the lowest y value it gets to was -3. X-intercepts, oh, they're a little bit messy. You can just kind of estimate them for now. We'll look at different ways to figure them out later. But in this case, I'd say, okay, maybe it hits that, and as long as you're close to these, maybe 1.8, 1.7. Down here, -1.8. And y-intercept hits the y-axis at -3. All right, next example, opening downwards. Vertex, it looks like that point, the turning point is -2 and 3. Axis of symmetry at x is -2. That splits it in half. Optimal value, the highest y value it gets to here. So it has a maximum here, a highest point of 3, or y equals 3. X-intercepts, it hits at -1 and -3. And y-intercept, that's kind of off the graph, but we can kind of take a guess here. I don't know, well, let's see, -6 maybe, somewhere down here. Yeah, you'd need a bigger graph in order to actually see where it hits.